Good afternoon, one and all present here. Correspondent Sister Shamala, Principal Sister Amy, faculty members, and my dear allies. Today, we all have gathered here for a Spark session organized by Department of Electronics. Can anyone tell the full name of Spark? Spark. The one who answers will get a chocolate. Yes. Yes. Spark means sharing past and recent knowledge. So our topic for today's Spark session is electronics in daily life. We have 6 groups ready with PPT presentation. Now call upon first group KTS and Vaishnavi, P. Sirisha and CH Saini.
From BSc Electronics Study. My teammates are P. Sirisha and Vaishnavi. Today our topic is microwave oven. Starting with the definition, microwaves are a form of electromagnetic radiation. That is, they are waves of electrical and magnetic energy moving together. Microwaves are used to detect speeding cars and to send telephone and television communication. Industry uses microwaves to dry and cure plywood, rubber and resins. But the most common use of microwave is in microwave ovens. Microwave ovens heat food using microwaves. It is a form of electromagnetic radiation similar to radio waves. Microwaves have three characteristics that allow them to be used in cooking. They are reflected by metal, they pass through plastic and aluminium materials, and they are absorbed by wood silicon. Next part will continue by Sirisha.
Good afternoon everyone. Coming to the components of microwave, we need to understand how each of those parts works. So, I break down the main parts of the microwave and uncover what each part does. First, high voltage transformer. Microwaves requires a high voltage of electricity to essentially function and heat food. Usually at the minimum level of between 3000 or 4000 volts. The high voltage transformer is able to convert the voltage to the much in the higher level. Magnet rod. This part of the microwave receives the high voltage of electricity supplied by the transformer and converts it into microwave energy to heat the food. The third one, waveguard. The waveguard is a component of the microwave oven that guards the waves. It is a hollow tube made from metal, which transmits and directs the microwave. Towards the cooking cavity, the microwave reflects back and front from the microwave waveguard in the cavity, passing through the food to heat it. Turntable. The turntable is a glass plate inside the microwave cavity, which is usually removable to make for easy cleaning. The purpose of the turntable is to rotate food around so that it cooks more evenly, avoiding hot or cold spots. The next section hand over to Vaishnavi.
So you all know what are the components of a microwave, right? So we need to know how they work together. So before we go into that topic, I want you to do a small activity. Will you do that? Okay? You will get prizes. Okay. So what you have to do is, I will count. On each count, you have to clap and then rub your hands thrice. Okay? So you have to do it fast. That's why I'm saying I will give you prizes. Okay? Clap once. Clap your hands once. Rub your hands thrice. Do it faster. Okay? I will count. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Who rubbed their hands thrice? Only one. Okay, I will go a bit slower for you. 1, 2, 3, 4, 5, 6, 7, 8, understand the components. Okay. Second thing is we don't need to know what is the working. We just put in the food, it will come out hot. And that's it. We don't need to know what is working. But since we are here, we need to know, right? So first thing is this microwave. It works on a concept. It works on the concept of electromagnetic induction. Okay. So we don't know what is the meaning of it, but study in the 10th if you remember, right? This is component, magnetron is there. From there you can see that there is magnet in it, right? Magnet. You know what, how it works, a magnet? What it does actually, it attracts, right? It has north and south pole, right? If you pass electricity to the magnet, it gives electromagnetic fields, right? So these fields are sent to the waveguide. Do you see that tube, waveguide tube? Those fields are sent to the waveguide, and those fields come out as microwaves, and those microwaves are sent to the cooking chamber. Okay, so let's suppose say I have put pizza inside. Your, it's all your favorite, right? It's uncooked. I have put the toppings, I have put it inside the microwave. Now I will turn on the microwave. Now what will happen? The turntable rotates the food. Have you ever seen microwaves? Yes, the food rotates, right? Why it does rotate?
So that it can evenly heat.
Yes, yes, it evenly cooks. What happens inside is these microwaves, they hit the food from all the directions. Hit, okay? Now we will go to the atomic level. Food has particles, millions of particles. Each and every particle is at rest right now. You have put inside the food, right? It is at rest, it is settled down. The microwaves, they hit the particle, they stand up. And all the particles stand up simultaneously. Now what happens when they stand? They hit each other, they rub each other. Now they rub each other and what happens? They fall again. Now again one microwave, it will hit again. So this process will continue and continue, and what is the output of it? You will produce heat, right? You all did this activity. What happened? It was hot, right? So the same thing is happening with the food here. So what happens after you turn off the microwave? Your pizza is ready. Bon appetit. Right? So that's the working of microwave. So that's all about the microwave. And yeah, there is another question that is frequently asked about microwaves. That is the food safe if we microwave it? Because radiation is there. So let me tell you one thing about it. Radiation has two types, inactive and active. Active radiation, under that X-rays are there. X-ray, UV rays, infrared rays, they all come under active radiation. Microwaves comes under inactive radiation. They are also radiation, but inactive. These microwaves do not damage the cells, but whereas the active radiation, X-rays and all, they damage the tissues and cells. So your food is safe. You can use microwaves. But in fact, one more thing is, if you microwave your food, the food which is cooked by the microwave and by the convention stoves, the nutritional value of microwave food is more. Why? Because when you cook your food on the stove, you put it on heat, right? The vapors are out. Your nutrition, they are all evaporated. But whereas in microwave, it's not completely cooked. Don't be in this imagination that you can cook your food inside microwave. You just use it for heating, right? You don't cook biryani or rice in the microwave, right? So yeah, that's all about microwaves. Thank you so much. Have a good day.
Group Preeti, Ashwini and Gayatri.
Good afternoon, everyone present here. So, in morning, to prepare tea from where your mom will take out milk packet from. Yes. Where do you store leftover food from last night? And where do you store ice creams?
Deep fridge.
I know everybody are super active right now. So, I, Preeti Susan of BSc MECS and my teammate Ashwini here to tell about how the refrigerator works. So, we will hear how the purpose of refrigerator. Can anybody tell me what is the purpose of refrigerator? To store food. We can even store food in cupboards. You said you can store food, no? Then, yes, that's correct. To stop food from spoiling, we use refrigerator because refrigerator it has a cool temperature. So the activity of bacteria stops the activity of bacteria to get spoiled. So that's the main purpose of refrigerator. So now let us see about the history of refrigerator. History of artificial refrigeration began with Scottish professor William Cullen designed a small refrigerating machine in 1755. Cullen used a pump to create a partial vacuum over a container of diethyl ether, which then boiled, absorbing heat from the surrounding. Now I'll hand over the mic to Ashwini.
Pros and cons of refrigerator. It helps to preserve foodstuffs so that they maintain their natural physical appearances. It helps to keep things cool. It has made possible the enjoyment of many foods throughout the year. Daily shopping is no longer necessary. It saves steps, energy and time. Everything has pros and cons. Now we look into the cons of refrigerator. The advent of no frost or automatic defrosting refrigerator and freezers have resulted in a tendency to clean these less frequently, so it results in food spoilage. If food spills are not wiped and foods are not covered in their order, may observe by another food in the compartment. As a result, the original flavor may be adrift. Conclusion. Lastly, we want to conclude that the fundamental reason for having a refrigerator is to keep food cold and fresh. But storing lot of food and not cleaning it properly. And after storing for a long time, it's very hazard to our health. Lastly, we want to say that fridge is not for luxury, it's for necessary. Thank you.
We call upon the third team, Jennifer, Anupama and Maitri.
Good afternoon everyone, my name is Jennifer and my teammates are Anupama and Maitri. So first of all, before beginning, I want you all to imagine something, okay? I'll tell you something, imagine that. Imagine being outside in the sweltering heat of a particularly hot summer day, doing God-forsaken errands that can no longer be postponed. The heat is so unbearable that it feels like the hottest day on earth since the dawn of civilization. But one thing keeps you on your toes, the knowledge that you will be in your air-conditioned house in an hour. The time has finally come. You open the door and enter your house. A gust of cool air envelops every cell of your body and you immediately feel better, right? Something like that? So I'm sure that you have all had this experience at least once in your life. The cooling revolution that air conditioners have brought into human society can never be described discounted. Though previous generations had fans and other ways to keep cool on hot days, they have never been astonishingly effective as modern air conditioners in terms of sheer cooling capacity. So there are two main types of air conditioners, that are window systems and split systems, which are further divided into mini split and central systems. In everyday languages, these are commonly referred as window AC or split AC. The main difference between the two is that window air conditioner has a single unit, whereas split air conditioner has two units, indoor and an outdoor one. Split is a lot more silent in operation as compared to window and looks aesthetically pleasing, but is relatively more complicated to install and requires more space as compared to window air conditioners. Regardless of the type of air conditioners, these all air conditioners consist of four main components which are listed below. First is evaporator. An evaporator is basically a heat exchanger coil that is responsible for collecting heat from the interior of a room by means of a refrigerating gas. This component is called an evaporator and is where the liquid refrigerant absorbs heat and evaporates it into a gas. This gas actually absorbs heat from the room and passes to the next component, that is compressor. Now, in the compressor, as the name implies, the gaseous refrigerant is compressed here. It is located in the outdoor unit, that is, in the part that is installed outside the house. Do you all know the square thing with a fan? That is the outside unit. And this is sent to the next part, which is called the condenser. The condenser absorbs the evaporated refrigerant from the compressor, converts it back into a liquid, and expels the heat to the outside. Of course, it is also located on the outside unit of the split AC. It comes out as water liquid whenever you switch on the AC. Cool water comes out from the AC. If the outside, if you have an AC, you'll know that. And the next is expansion valve. In the expansion valve, also known as throttle device, is located between the two coils, the cooling coils of the evaporator and the hot coils of the condenser. It controls the amount of refrigerant moving towards the evaporator. Note that in the case of window ACs, the three components mentioned above are all located in a small metal box installed in a window opening. These are the main components of an air conditioner. Now Anupama will explain the working to make an air conditioner to do what it does.
So coming to working, when the supply is on, the higher current flows in the motor starting winding. You can see the fan motor in the first picture. This place is where the high current flows, and it starts and also relays contact, flows and connect the starting capacitor to the starting winding. As the motor gradually reaches the normal speed, the current in the running winding decreases, making the relay open, thus disconnecting the supply to the starting winding of the motor. The overload protector protects the motor against excessive overload. This protection is provided inside the compressor, and its function is to open the compressor more circuit. So we know that every device is built on basis of any electrical circuit. Similarly, AC is built on an electric circuit, and we'll see the main components. The first main component is, as I said, fan motor. In AC, a 5-split phase motor is used as a fan motor. The fan motor is provided with an overheat protection placed in winding so that the event in overheating is protected. And the second one is starting capacitor. You can see in the first picture the starting capacitor CS. This has large capacitance. Do anyone know how is capacitor measured in any terms? Anyone? How is capacitor measured? No one? The capacitor is given in terms of volts, whereas its capacitance is in microfarads. It remains in the circuit for a short time till the motor starts. And the third component is running capacitor besides starting capacitor. The running capacitor has small capacitance but heavy duty and are oil filled. It remains in circuit continuously and improves the starting torque and power factor. And the fourth and the last important component is thermostat. The function of thermostat is to monitor the room temperature and start or stop the motor. When the room temperature is increased, the contact of the thermostat close and the start the compressor. When the temperature decreases, the contact open up and the compressor of the air conditioner stops. And the disadvantages and advantages are discussed by my colleague.
I want to ask you all a question. How many people during the summer holidays went to the ATM and never wants to come back in their childhood days? Only few hands are raising. All are lying, I think so. Till now I go to the ATM and never wants to come back. Okay, I continue with the advantages and disadvantages. Most people use air conditions to stay more comfortable in their homes, offices during hot and humid summer weather. Under extreme conditions, air conditioner may keep elderly and other vulnerable people safer from heat-induced health problems. Air conditions are used in many commercial settings not only for increased comfort and also for decreasing the heat stress on delicate machinery such as computers and reducing food spoilage in grocery stores and restaurants. And the advantage number one is prevents dehydration and heat strokes. Being exposed to the heat for longer periods can cause dehydration. Does anyone know dehydration here? Come on, Divya. Yeah, it's partially. The less amount of water present in our body is also known as dehydration. Staying in an AC can reduce the dehydration as it will be humid and the result of dehydration will not occur. Heat strokes were another problem to treat excessive heat can cause this because too much of heat make it difficult for the body to regulate the temperature. If the heat problem is enough to cause a damage to the brain and other organs of the body. Since air conditioners reduce the temperature of the air, they can helpful in preventing heat strokes. Improves quality of air. Air conditions can significantly improve indoor and all quality and create much healthier atmosphere. This is because they are capable of filtering out pollen, dust and another allergies present in the environment by reducing humidity, air conditions and can check the growth of microbe and mold. It helps to reduce the asthma and allergies. Air conditions can help to filter out as well as disinfect all the air we breathe. This can reduce the risk of asthma and attacks and allergies by removing pollen and dust. Disadvantages. Air conditions use lot of electricity. This creates both financial and disadvantages for the people who have to pay for the power. And generalized environmental disadvantages cause power production because large percentage of coal, burning plants and air conditioners contributes indirectly the release of greenhouse gases and other pollutants. In addition, according to the independent spending too much time in air-conditioned environment can contribute to health problems such as asthma, tightness in the chest and other respiratory problems. How many people present here follow a skin routine? Like applying moisturizer, hand creams, face creams. Only two people. Okay. Skin dryness. Spending increased moisture, thereby becoming sensitive and dry. It can also cause irritation and dryness of mucous membrane. Aggravation of respiratory problems. A sudden change in temperature has shown to exacerbate the symptoms of various respiratory diseases and reduce it by higher temperature. Respiratory tract infections and allergies. Not only cleaning the AC condition can cause the building of the dust, bacteria and pollen in the air filters and significantly increase the risk of asthma and respiratory infections. Thank you.
Thank you, girls. Now I call upon the fourth group, Nancy, Aisha, and M. Chandana.
Good afternoon to everyone present here. I'm Aisha from BSc to Electronics and my teammates are Chandana and Nancy. And we are here to talk about the working of inverter. So can anyone say what is an inverter or have you ever heard of word inverter? So what does it do? Yeah, it replaces if at all you have observed when current goes in a society, one of the house or like two maybe, they have the lights on. Like I have you ever wondered why their lights are on and only current is gone in our house? They have the inverter. They use inverter in place of that electricity. Some maybe they put some to electronic like fans or lights in the inverter and they will be on whenever the current is gone in a colony. So what is an inverter? An inverter is an electric apparatus that changes direct current into alternating current. Next is introduction of an inverter. An inverter is a motor control that adjusts the speed of an AC induction motor. The inverter is a static device. It can convert one form of electrical power into other form of electrical power. Hence, the inverter is the inverter, not a generator. The next is the history of inverter. David Prince probably coined the term inverter. From the 19th century through the middle of the 20th century DC to AC power conversion was accomplished using rotary converters or motor generator sets. In early 20th century, vacuum tubes and gas-filled tubes began to be used as switches in inverter circuits. In India, the inverter was manufactured in the year 1978 and the first solar inverter back in 1995. David Prince probably coined the term inverter. Toshiba invented inverter in 1980. The next slide is explained by Nancy.
Till now we learned what is inverter, so let's learn about what is the working of inverter. In an inverter device, there is a inverter circuit and capacitor, and alternating current and direct current. So what is an alternating current, does anyone know? And what is the difference between AC and DC? So DC is known as direct current, makes voltage or current that goes in one direction, and AC is known as alternating current which goes in different direction or changes the direction over time or respectively. So here alternating current. So here we can see power supply and back to the motor. So alternating current converter circuit converts the alternating current to direct current, and this process is known as rectification, and the alternating current is in the form of sine waveform, and direct current is in the place of capacitor, and capacitor stores the current there and discharges the direct current to inverter circuit, and inverter circuit outputs the alternating current. This process is known as PWM. This is known as
Pulse width modulation. Here we can see the diagram of the sine wave and the graph diagram. Pulse width modulation. The good definition of pulse width modulation is in the name itself. It means modulating and verifying the width of the pulse, not the frequency. When we on a switch, there is a ranges high, medium, and low. So when we on the switch, there will be high ranges, right? So when we on the switch, we can see the waves will expand. When we lower the switch, the waves will be middle, like it contains very small. So this is known as inverter of device. So let's learn about types of inverter. Types of inverter. According to there are types of in the types of inverter, there is an output waveform and a type of load. In an output waveform, there are three types: square wave inverter, modified sine wave inverter, sine wave inverter. And according to type of load, there are two types: single phase inverter and three phase inverter. In single phase inverter, meaning is the current which goes from single phase, and three phase inverter used to convert a DC input to AC output. So in a single phase inverter there are two types: half bridge and full bridge. Half bridge converts DC voltage to AC voltage, and full bridge converts DC power to AC power. In three phase inverter there are two types: 120-degree mode of conduction and 180-degree mode of conduction. 120-degree mode of conduction which has only till 120 degree of Celsius, and 180 degree mode of conduction will have only till 180 degree of Celsius. The next slide will be explained by Chandana.
As you all heard about working, history and what is inverter, let us know a small part of inverter, applications of inverter. Inverter is used in UPS as batteries, and it is used as solar panel. In applications, in inverter we use houses, we only use lights, fans and etc. But we don't use all the applications and appliances in the house, because inverter is used only for the purpose which are the only essential things in the house. We don't keep inverter for all the things like lights, switchboards, all the things, right? We don't keep the inverter, we don't connect inverter to everything in the house, right? And we use HVDC transmission, and inverter is also used for backup purpose. Advantages of inverters. It can be energy efficient way of changing voltage, and it can be used as step voltage up or down. It can inverter has a special thing that it controls the voltage whenever, and it also has limited voltage that we can't connect anything in the house, that we can connect only to things which are precious, and it can provide electrical isolation between input and output. It can provide AC voltage from a DC source. The inverter converts DC source into AC voltage, as direct current is not used in our homes because it may lead to short circuit, and it can smooth out random variations in input voltage. It can be used to produce 50 Hz from a 60 Hz supply or vice versa. Disadvantages of inverter. It requires rectification and smoothing on the output if the output is to be DC. In converting of DC circuit into AC current, we use rectification and smoothing, and it may produce radio interference or audible tones. It may produce AC at non-specific frequency. In certain types of UPS, the inverter may need to phase synchronized to the input AC power to ensure a spike-free switchover. It may produce excess output voltage under no load or very light load conditions. Actually, inverter converts only electrical energy, that's it. But generally, it is
inverter and generator. Inverter is only it only converts one form of energy into another form of energy, but it is not like generator. Thank you, everyone.
Now I call upon the fifth group, Harita, Vanishri and Navya.
Good afternoon to everyone. I am B. Vanishri of BSc second year and my teammates are Harita and Navya. Today our team and I are here to share some information about biometric machines. Now let us know what is biometrics. Biometry. Bio means life and metry means to measure. Biometric is the science and the technology of measuring and analyzing biological data. Biometrics are automated method of recognizing a person based on the physiological or behavior characteristics. My teammate Harita is going to share about types of biometric machines.
Types of biometric machines. We have two ways. We can divide it into two modes, identification and verification. Where in identification, we can, if we have a one set of, like we need a one fingerprint to know whose it is, we can compare it with one to many. And verification, one to one. We have facial recognitions. We most of us use facial recognition in our phones, like where it is already stored. If we give a facial recognition, then whenever we want to on our phones, we keep our faces instead of locks. Next is our fingerprint. Fingerprints are also same as facial recognitions where we already store our fingerprints. Nowadays we are even getting for locks of doors where if we forget keys directly we can keep our fingerprints. Next is hand geometry. This geometry checks our hand width, length, all the measures and check if it is ours or not. Next, come to iris. Iris, here it checks the iris of the eye, like pupil, everything. Next is the voice recognition. In our phones, all have Google, right? Where we use Google for writing a notes. If there is lengthy matter to type, instead of typing it, we use voice recognition. Next is signature verification. Banks checks can be gone, or anyone can do a malpractice like doing others can sign ours. So instead of doing that, we'll have banks will recognize few signs. So where we use it in banks. Next now I Pavani to work.
A biometrical occurs control system is a pattern recognition unit that gather a specific types of biometric data from a person which focus on a relevant feature data. Occurrence of a comparison. There are the varieties of characteristics that can be used from a biometric comparison such as fingerprint, iris, hand, geometric, voice pattern, etc. Although there are few limitations. It standard biometric access control system is composed of four main types of comparison: a scanner device and equality assignment unit. A features comparison matches unit like a database. One. Harita.
Everything has advantages and disadvantages. Where the biometric advantages are, it is secure and it is not transferable and it is hard to fake or steal.
The disadvantages is it is a costly and the database can be hacked by anyone, and few of the biometrics have the limitations, and machine algorithm should be advanced every time. Now I hand over the session for Vani to conclude.
Biometric, biometric technology is very inexpensive and easy to use for many applications area. Criminal identification, prison security, ATM, aviation security, database access, home or office. Biometric fingerprint recognition system allow for increased security, convenience and accountability while detecting and returning fraud. Biometric conclusion is one of the best and strongest security feature to benefit individuals and any institution. Thank you.
Thank you, girls. Now I call upon the last group, Lalita, Mallishwari and Omakshi.
Good afternoon everyone. I am Lalita and my teammates are Omakshi and Maheshwari. Today we are here to discuss about refrigerator, and in this session we are going to learn about the working principle, construction, current flows and voltage flows of a refrigerator. Now I hand over this to Omakshi to further discuss the topics.
Working principle. Refrigerators work by causing the refrigerant circulating inside them to change from a liquid into a gas. This process called evaporation cools the surrounding area and produces the desired effect. Construction. Refrigerator today consists of several basic components: the exterior cabinet and door, the inner cabinet or linear, the insulation inserted between the two, the cooling system, the refrigerant, and the fixtures. The cabinet and door are made of aluminium or steel sheet metal that is sometimes pre-painted. Next will be continued by Maheshwari.
Current flow. The average home refrigerators use 350 to 780 volts. Refrigerator power usage depend on different factors such as what kind of fridge you own, its size and age, the kitchen's ambient temperature, the type of refrigerator and where you place it. Different type of fridge have different power requirements. Voltage flows of a refrigerator. Any refrigerator that plugs into a standard wall outlet runs at a voltage of 120 volts, which is basically the same as 120 volts or even, as you might find listed on some applicants, 115 or 110 volts. In other words, the refrigerator voltage is the same as the voltage of an LED TV or that of any other applicants that plugs into a outlet. Thank you.
Thank you, girls. I would like.
Here I am again to tell the parts of refrigerator. When I actually we forgot to tell this, but it's very disappointing. Nobody, we didn't tell working and parts of refrigerator. I was like, wow, nobody is interested in learning. came here and everybody are little disappointed to see me here again. But whether you like it or not, I'm going to tell you. So these are the parts of refrigerator: compressor, evaporator, condenser coils, expansion valves and refrigerants. So the work of compressor, this is the heart of a refrigerator. It circulates the refrigerant toward the system, pressure to warm part of the circuit and makes the refrigerant hot. It is similar when you are pumping air into a bicycle tube. Next one is condenser coil. The condenser sits on the back of a refrigerator and it's likely quite dusty. Inside the refrigerant is cooled down and condenses, meaning it turns from a gas back into liquid. Evaporator. The evaporator is located inside a refrigerator and is the part that makes items in the refrigerator cold, as the refrigerant turns liquid into gas through evaporation. Next one is expansion valve. The thermostatic expansion valve allows you to keep a constant superheat or refrigerant level at varying load situation in refrigeration system to save energy. And the last one is refrigerant. Refrigerant is chemical compound that used as heat carrier which changes from gas to liquid and then back to gas in refrigeration circuit. Now we'll see about working of refrigeration. The compressor constructs the refrigerant vapor, raising its pressure and pushes it into the condensing coil on the outside of the refrigerator. Then the hot gas in condensing coil meets the cooler air temperature of the kitchen. It becomes liquid. Now in liquid form at high pressure, the refrigerants cool down as it flows into the coils inside the freezer and the fridge. The refrigerants are inside the cooling the air. Last, the refrigerant evaporates into a gas, then flows back to the compressor, where the cycle starts all over. Last, I want to tell that when you use something, any device, you have to know that the working of the device, not just use it like we got it, we have to use it. So we have to know how to use. Thank you.
Thank you, Preeti. I would like to call SCPO to propose vote of thanks.
A pleasant afternoon to everyone present here. As we come to an end today's session, on behalf of our department, I, Divya from BSc 3, take this opportunity to propose the vote of thanks. Firstly, I would like to thank our principal Sister Ami and our dear faculty to conduct this section, and I would like to thank you all for joining us today. I extend my gratitude to Pallavi ma'am and Srinivas sir for technical support. Last but not the least, I would like to thank you all, dear Anna, for active participation. Thank you everyone. Have a great day.